All right, so this is 8.2, distribution of the sample proportion. So suppose that a random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristic. The sample proportion is given by, and this symbol right here, you have the part of a triangle over a letter. That's called our hat symbol, so that's p hat. So the way you would calculate that sample proportion is x over n, where x is the number of individuals in the sample with a specified characteristic, and the sample proportion, and we know n is the number of our sample size. So the sample proportion is a statistic that estimates the population proportion. So as always, it'll make more sense once we put numbers on it, and you'll see what we mean by that. So when we do this calculation, it's going to estimate, what goes on with the population. We're going to use our sample to estimate what goes on with the population. All right, and then as far as symbolism goes, P is your population proportion. P hat is going to be your sample proportion. All right, make sure we're good before we go to the next page. All right, we okay? All right, so let's look at an example that uses this. We have computing a sample proportion. The Harris poll conducted a survey of 1,200 adult Americans who vacationed during the summer and asked whether the individuals plan to work while on summer vacation. Of those surveyed, 552 indicated that they plan to work on vacation. Find the sample proportion of individuals surveyed who plan to work while on summer vacation. So I'll give you a chance to write it down. All right, so you want to find the sample proportion. So we have a Harris poll that was conducted, and they surveyed 1,200 people. So that is the sample out of the population. 1,200 was taken out. Then out of the survey, 552 plan to work on vacation. That's the characteristic that we're dealing with. So that's why X is 552. So the sample proportion is X over N, which is 552 over 1200, 0.46. So the Harris poll estimates that 46% of adult Americans who vacation during the summer plan to work while on vacation. So they use the sample that they have to um, estimate or predict how the population will respond. All right, questions? Any questions? All right, anybody still copying this page? All right. All right, the sampling distribution of p hat, our sample proportion, says for a random sample size n with a population proportion p, the shape of the sampling distribution of p hat is approximately normal, provided that n times p times 1 minus p is greater than or equal to 10. And so that's important because if it's approximately normal, that means we can use z-scores. So that's what I get right here in red. You can use z-scores. The mean of the sampling distribution of p hat is going to be our p, whatever our population proportion is. The standard deviation of the sampling distribution is going to be calculated by the square root of p times 1 minus p over lowercase n. All right. All right, so example that's going to use that that setup says according to the National Center for Health Statistics, 15% of all Americans have hearing trouble. In a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? Suppose that a random sample of 120 Americans who regularly listen to music using headphones result in 26 having hearing trouble. What might you conclude? So give you a chance to write that, and then we'll do the problem. All right, so everybody finish with this page. All right. So first thing we'll do is write down our givens. So is the sampling distribution approximately normal? First thing we look at the fact that N, our sample size is 120. And this time they gave us the population proportion, which is 15%, 0.15. So we can test to see if it's approximately normal by doing N times P times 1 minus P. And if it's greater than or equal to 10, then it is going to be approximately normal. So we did 120 times the 0.15 times 1 minus 0.15, which is 15.3. And we see that that is greater than 10. All right. So since that is the case, the sampling distribution is approximately normal, and that means z-scores can be used. So that's what we did there in the red, just to solidify that it is approximately normal. All right. So looking at A, we have P hat. They gave us our sampling distribution, which was 12%. We said out of the sampling, 12% fit the characteristics. And then our mean is going to be at 15%. That's the population proportion. To calculate your standard deviation, we'll do the square root of P times 1 minus P over N. Made a little error right here over the N, so I scratched that out. So that shouldn't be there. It's just supposed to be N, which is that 120. So it's 0.15 times 1 minus 0.15 over 120. And that gave us 0.032596. So now we have our X, we have our mean and our standard deviation right here. And remember I said we could use our z-scores, which is how we would do it. This is how we would set it up. Our X is our P hat. The mean of our sampling distribution or sampling proportion is this 0.15. Standard deviation of our sampling proportion is 0.032596. And that gives us negative 0.92. So before we go any further, make sure we're okay with what we've done. Where we got our numbers from. All right, so go to the chart, take the negative 0.92, go to the chart. That gives us 0.1788. And remember, the chart always gives us less than. And so here in the red, since the question asks at most, this means we want less than. And so the chart value is the answer. So if you're talking about at the most, you know, in other words, it can't be any more than. So you want everything less than, and then that number right there. So when you say at most, you're talking about the less than, everything to the left of that value. If it's at most, you don't want anything greater than that. You want everything that and less than. So the probability that a random sample of 120 Americans results in at most 12% having hearing trouble, it's going to be 0.1788. Any questions? All right. Anybody still copying? All right, so going to B, we want to suppose that a random sample of 120 Americans who regularly listen to music using headphones result in 26 having hearing trouble. What might you include? Okay. All right. So they give us X is 26, 26 having hearing trouble. That's the characteristic that we're talking about. So don't forget we need our P hat. P hat is X over N. So we do 26 over 120. That gives us 0.217. And then from the previous calculation, we're still in the same problem. So what we did in A still holds true. Our mean of our sampling proportion is 0.15, and the standard deviation of our sampling proportion is 0.03256. All right. So with that information, we can find our z-score. P hat minus the mean of our P hat, our sampling proportion divided by the standard deviation. So 0.217 minus 0.15 over that 0.032.596. That gives us 2.06. And then once again, as we have our z-score, we go to the chart. And that gives us 0.9803. And once again, whatever value we get from the chart is going to be our less than. So I'll give you a chance to write that, and then we'll interpret. All right, so in the red we see here, since the question asks what might you conclude, we should explore greater than to see how unusual this value is, or this proportion is. So 1 minus the 0.9803, that chart value, will give us 0.0197. So the proportion is less than 5%, or 0.05. And that was our marker that we talked about, determining whether something's unusual or not. And so this means it is an unusual occurrence. All right. And that just means the results obtained are unusual. Questions? Any questions?
I have a question, but it's not about 8.2.
All right.
I was absent for the 8.1 notes,
Mm-hmm.
and I was wondering if sometime today you could post them so I can just catch up in my math lab.
Yeah, I'll be posting them soon. The plan was to post them this weekend, but got caught up, so it should be out this evening. But no
Okay.
later this evening. Yeah.
Okay, thank you.
Yep, no problem. All right, is everybody good? Anybody still copying? All right. I think we got one more. Oh, there you go. So, so looking at our last problem, we were talking about how unusual it is and what could you conclude. So it says we could make one of two conclusions. The population proportion of Americans with hearing trouble who regularly listen to music using headphones is 0.15, and we just happen to randomly select a higher proportion that have hearing trouble. So, in other words, looking at, we're talking about how unusual it is to have that amount of people to have hearing trouble. So, it's saying that, maybe it's just that the people that we chose had hearing trouble. And then number two, the population proportion of Americans with hearing trouble who regularly listen to music using headphones is more than 0.15. And so that one is more, more reasonable. So in other words, instead of just the people that we chose had hearing trouble, it's the fact that they're using headphones regularly is the reason why they have hearing trouble. In other words, that's contributing to them having hearing trouble. So that's just they ask you what conclusion could you make from the information that you had. So those are the two conclusions that you could come up with, and the second one is more reasonable that the headphones are actually contributing to them having hearing trouble or the regularly usage of the headphones. All right. Questions on anything I've written so far? All right. Is everybody good? Still copying? Anybody? Let me see. Yep. So that is he only gave us two examples. Okay. Let's do this. All right, so where we are at this point is that we're looking at test. This is our fourth test, last test that we'll be trying to take. 7-1, 7-2, 8-1, and 8-2. And so, last time we tried to take a test, my math lab wouldn't let us. So we do want to try to get this one in proctored. And today is the 4-7. So how about next Wednesday? So that'll give you, if you're looking at the calendar, today is what, the 29th, 31st. So this will be the 5th. This would be the 7th. So we're talking about the 7th right here. So as far as reviewing, we can review Wednesday and Monday. So this Wednesday coming up and Monday. So the way we'll do it is that on the 4th, not the 4th, on the 7th, proctored test. And then on that same day, with our class starts at 9:30. And on that same day, the makeup will be posted. So I guess around 12 or so. So the difference between the proctored test and the makeup, highest score you can make up here is 100%. Highest score you can make on this one is 85. So same thing that we were going to do with the first test that we tried to take proctored is that there will be a makeup that will be posted after the proctored test. High score you can make on is 85. Once again, I'm not going to take 15% from your grade. So if you score 75, I'm not going to minus 15% from it. It's just saying that the cap is going to be 85 on it. So if you were to score an 80, then your score is an 80. But if you score 95, then I would take that as an 85. All right. So questions on that? Got it good? Everybody straight? Okay with what I'm saying? All right. So Wednesday and Monday, this Wednesday coming up and next Monday, I will not be doing anything new. I will just be reviewing according to the questions that you have. If you don't have any questions, if you went through my math lab and you don't have any questions, I guess you don't really have to show up either one of those days. And then on actual test day, if you know legitimately you aren't ready for the test or just not prepared, then you don't have to force yourself to take the test. You will, like I said, that makeup opportunity will be posted and you take it on your own time. It's just that the highest score you can get on is 85. If you've done everything you're supposed to do, scoring at 85 is only 5 points from an A. That will not stop you from getting the A out of the course if that's your desire. So it's a penalty, but at the same time, it really doesn't prevent you from getting the highest grade possible out of the course. So questions on anything? Questions on setup? Questions on anything I said? All right. So that's it for the lecture. What I can do now, like your classmate mentioned, I have those videos to get out. What I can do is go ahead and make that now. Hopefully I can get it done before my next class and go ahead and shoot that 8-1. I'll shoot both of them to you, 8-1 and 8-2.
Thank you.
Oh yeah, no problem, no problem. Any other questions or concerns before we close? All right. Well, you guys have a good one. Be safe, and I will see you on Wednesday. All right. Take care.